Question 30 says that the work done in moving a unit positive charge from one point to another against the electric field is a measure of. We know that the potential difference V between 2 points in an electric field is defined as the work done per unit charge Q to move the charge from one point to another. Mathematically, it is given by V is equal to work done divided by Q. When we move, when a moving unit, when moving a unit positive charge, the charge is equal to 1. The potential difference will be equal to the work done. Therefore, we can say that option C is correct answer, which is potential difference between 2 points. Question 31 says that the capacitance of parallel plate capacitor is given by. We know that the formula of capacitance is this. Here A is the area of one plate, epsilon naught is the permittivity of free space, also known as the vacuum permittivity, and D is the separation between the plates. Hence, option B is the correct answer. Question 32 says that two charged particles placed in air at a distance of 0.5 meter exerts force on each other. If these charges are placed inside mica at same distance, then the new force between the charges will be. We know that the force between two charges in a medium is given by the Coulomb's law. So we can write it as F is equal to 1 over 4 pi epsilon naught into Q1 Q2 divided by R square. In a medium with dielectric constant K, this force will be F medium is equal to 1 over 4 pi epsilon naught K into Q1 Q2 divided by R square. We know that the dielectric constant of air is approximately 1. So the force in air will be force air is equal to 1 over 4 pi epsilon naught into Q1 Q2 divided by R square. The force in air is equal to the Coulomb's force, hence we can say that F is equal to F air. Now, when the charges are placed in mica, the dielectric constant of mica, K mica, is greater than 1, typically around 6 or 8. So, the force in mica will be F mica is equal to 1 over K mica into the force. Since we know that the K mica is greater than 1, it follows that the force mica will be smaller than the actual force. Hence, option A is the correct answer. Question 33 says that energy density in case of a capacitor is always proportional to. The energy density, which is U, in a capacitor is given by the formula which is U is equal to 1 over 2 epsilon into electric field square. Here, U is the energy density, epsilon is the permittivity of dielectric material, and E is the electric field. From this formula, we can see that the energy density is proportional to the square of the electric field, which is E square. Hence, option A is the correct answer. Question 34 says that when we double the voltage in a simple circuit, we double the. According to the Ohm's law, we know that V is equal to IR. From this, we can say that V is directly proportional to current. So if we double the voltage, the current will be doubled as well. Hence, option B is the correct answer. Question 35 says that the charge of an electron is 1.6 into 10 raised to the power of minus 19 coulomb. How many electrons strike the screen of a cathode ray tube each second when the beam current is 16 milliampere? In the question, we have the charge of the electron, which is E, and we have the current, which is 16 milliampere. So we can say that this current is equal to 16 into 10 raised to the power of minus 3 amperes. We have a formula which is I is equal to Ne divided by T. By putting values, we will get 16 into 10 raised to the power of minus 3 is equal to N into 1.6 into 10 raised to the power of minus 19 divided by 1, as the time is 1 second. Now, when we will solve for n, we will get 10 raised to the power of 17, which is option C. Hence, option C is the correct answer. Question 36 says that two bulbs of 100 watt and 200 watt are connected in series to the mains. The ratio of current through them is when two bulbs are connected in series. The current flowing through each bulb is same because there is only one path for the current to take. For example, I have this bulb here and then this bulb here. Now here we can see that the current has a single path. Hence the current remains same. Therefore, regardless of power rating of the bulbs, the current through each bulb in series will be identical. Hence option D is the correct answer. Question 37 says that if internal resistance of a supply is 0, then we know that Vt is equal to E minus IR. Here Vt is the terminal velocity, I is the current and R is the internal resistance. If the internal resistance is 0, the Vt will be equal to E minus I into 0. So we will be having Vt is equal to E. Hence, option C is the correct answer. Question 38 says that the equivalent resistor between A and B will be, as we can see that if the current follows this path here, these three resistors are connected in series. So equivalent resistance 1 will be 1 plus 1 plus 1, which is equal to 3 ohm. Now if I redraw this circuit here, so this circuit will become this. Now here we have this path and this path. As we can see that these both resistors are parallel and they are equivalent as well. So we can say that the equivalent resistance is equal to R divided by 2. Hence we can write as 3 divided by 2, which is equal to 1.5 ohm. Hence option A is the correct answer. Question 39 says that when a current carrying conductor is placed in a magnetic field, it moves from a region of, we know that the movement of current carrying conductor in a magnetic field is explained by Lorentz force. When a current carrying conductor is placed in a magnetic field, it experiences a force which is given by F is equal to I into L into B. Here F is the force, I is the current, L is the length vector, and B is the magnetic field. The force experienced by the conductor does not directly depend on the strength of different regions of magnetic field, but the conductor generally moves from a region of stronger magnetic field to a region of weaker magnetic field. Hence, we can say that option A is the correct answer. Question 40 says that which of the following particles has greater E or M ratio? If we talk about charge to mass ratio, we know that the charge on electron is minus 1.6 into 10 raised to the power of minus 19 coulomb, and the charge on proton is equal to 1.6 into 10 raised to the power of minus 19 coulomb. The charge on alpha particle is equal to 2 into 1.6 into 10 raised to the power of minus 19 coulomb, and the charge on neutron is equal to 0. Then we have the mass. If we talk about the mass of the electron is 9.11 into 10 raised to the power of minus 31 kilogram. If we talk about the mass of the proton is 1.67 into 10 raised to the power of minus 27 kilogram. And if we talk about the mass of the alpha particle, the mass of the alpha particle is equal to 4 into 1.67 into 10 raised to the power of minus 27 kilogram. And at last, if we talk about the mass of the neutron, we have 1.67 into 10 raised to the power of minus 27 kilogram. Now, if we calculate the electron or mass ratio, it will be the highest for the electron. Hence, option A is the correct answer. Question 41 says that when a bar magnet is broken into two pieces, when we break a magnet into two, both acts as magnet. For example, here I have a magnet. If I break it into two parts, both of these magnets have a north pole and a south pole. And you can see that in both of these pieces, the corresponding north and the corresponding south pole remain on the side as in the original magnet. Hence, we can say that each piece will have two unlike poles. Question 42 says that an electron enters a magnetic field at right angle to it as shown in the figure. The direction of the force acting on the electron will be. To solve this, we will use the right hand rule. Point your thumb in the direction of the velocity and point your index finger in the direction of the magnetic field. Your first finger, perpendicular to both, will point in the direction of the force for a positive charge. Hence, we can say that the force will act out of the paper, which is option C. Question 43 says that two parallel wires carrying current in same directions. Here I have two wires. The current in both of these wires has the same direction. Now, both of these wires will have a magnetic field of their own, and they both will be present in the magnetic field generated by the other wire. Hence, they will attract each other, which is option A. Question 44 says that the Lenz's law refers to induce heat, current, resistance, or capacitance. We know that the Lenz's law is given by E is equal to minus d phi of B divided by dt. Here E is the induced EMF and phi B is the magnetic flux. So from the formula, we can say that the induced EMF with different polarities induces a current whose magnetic field opposes the change in magnetic flux through the loop in order to ensure that the original flux is maintained through the loop when current flows in it. Hence, we can say that the Lenz's law induces the current. Hence, option B is the correct answer. Question 45 says that in electromagnetic induction, the induced EMF in a coil is independent of, as we just studied in the previous question, that according to Lenz's law E is equals to minus d phi b divided by dt. In this formula, you can see that we have the change in flux, which is phi b. Hence, we can say that it is not independent of the change in flux. Talking about the time, here we have the time. So we can also say that it is also not independent of the time. At last, we have the resistance of the circuit. In this formula, we don't see the resistance. Hence, we can say that the resistance of circuit is the correct answer, which is option A. Question 46 says that in a circuit with a coil of resistance 2 ohms, the magnetic flux changes from 2 Weber to 10 Weber in 0.2 seconds. The charge that flows in the coil during the time is. According to the Faraday's law, we know that E is equal to del phi divided by del T. Here we know that E is equal to IR. So we can write it as IR is equal to del phi divided by del T. Now we can say that I is equal to Q over T. So we can write it as Q over del T is equal to del phi over R del T. This del T cancels out this del T, so we can write it as Q is equal to del phi divided by R. We can also write it as phi F minus phi I divided by R. So in the question, we have the resistance, we have initial magnetic flux and the final magnetic flux. So by putting values, we will get 10 minus 2 divided by 2, which is equal to 4 coulomb. Hence, we can say that option B is the correct answer. Question 47 says that the number of turns in primary and secondary coil of a transformer are 100 and 300. If the input power is 60 watt, the output power will be. In an ideal transformer, the power input to the primary coil is equal to the power output from secondary coil. So we can write it as P primary is equal to P secondary. Hence, we know that the power primary is 60 volts. So the power secondary will also be 60 volt. Therefore, option B is the correct answer. Question 48 says that whenever there is a change in the magnetic flux linked with a closed circuit, an EMF and current are induced in the circuit. This statement is referred to as the phenomena described in the basis of electromagnetic induction, which is governed by Faraday's law of electromagnetic induction. Specifically, the statement refers to the Faraday's first law of electromagnetic induction, which states that EMF is induced in a circuit whenever there is a change in the magnetic flux linking the circuit. Hence, we can say that option D is the correct answer. Question 49 says that which of the following quantity remains same in non-ideal transformer? In a non-ideal transformer, some quantities may change due to energy loss like heat and insufficiencies in the magnetic coupling. However, we know that the current, voltage and power changes, but the frequency remains same. Hence, option C is the correct answer. Question 50 says that in full wave rectifier with input frequency 10 Hz, the ripple in output is mainly of time period. In a full wave rectifier, the new frequency becomes double. And in the question, we have the input frequency. So we can write it as 2 into 10, which is equal to 20. So the time period will be 1 over the new frequency, which is equal to 1 over 20, which is equal to 0.05 seconds. Hence, option D is correct answer. Question 51 says that which of the following devices can be used as rectifier? A rectifier is a device that converts AC to DC. We know that diodes are primary component used for rectification because they allow current to flow only in one direction, efficiently blocking the reverse flow of current. This property makes diodes ideal for converting alternating current, which means the answer is option A, which is diode. Question 52 says that the slope of energy and frequency graph is equal to. We know that the relationship between the energy of a photon and its frequency is given by the equation, which is E is equal to hf. Here h is a Planck's constant. Therefore, when we plot the energy against frequency, the slope of the graph is equal to Planck's constant. Hence, option D is correct answer. Question 53 says that in Davison-Germer experiment, the diffracted electron beam from crystal shows that Davison and Germer showed that electrons can exhibit diffraction patterns. The experiment provided direct evidence of the wave-particle duality of matter, confirming that the particles such as electron can behave as waves. Therefore, we can say that option C, which is wave property, is the correct answer. Question 54 says that the energy of gamma ray photon is approximately equal to. The energy of gamma ray photons is much higher compared to other type of electromagnetic radiations, usually in the range of kilo electron volts to several mega electron volt. Specifically, gamma ray photons often have energy around 1 mega electron volt. Therefore, option A is the correct answer. Question 55 says that the radiation emitted from hydrogen-filled discharge tubes show when the hydrogen gas in a discharge tube is energized, electrons move to higher energy levels and then fall back down, emitting light at specific wavelength. This produces a series of discrete lines, which are known as line spectra. Therefore, we can say that option B is the correct answer. Question 56 says that Bohr's model can explain. We studied that the Bohr model is only valid to atom or ion that is having only one electron, such as hydrogen, helium with positive sign, lithium with +2 charge, and beryllium with +3 charge. Therefore, we can say that The spectrum of atom or ion containing one electron only is the correct answer, which is option C. Question 57 says that what percentage of original radioactive atoms decay after 6 half-life? We know that fraction remaining is equal to 1 by 2 ratio power of n. According to the question, the n is 6. So we can say that the fraction remaining will be 1 over 2 raised to the power of 6, which is equal to 1 over 64. To find the percentage of atoms that have decayed, we have to subtract the fraction remaining from 1 and then convert to a percent. So we can say that the fraction decayed is equal to 1 minus 1 over 64, which is equal to 63 divided by 64. Now if we convert it into the percentage, it will be equal to 63 divided by 64 in 200, which is equal to 98.44%. Hence, option A is the correct answer. Question 58 says that a certain radioactive mass decays from 128 gram to 2 gram in 42 minutes. What is its half-life? To find the half-life, we need to determine how many half-life it takes for the mass to decay to 128 gram to 2 gram. Now, we know that after first half-life, 64 gram will be remaining, and after second half-life, 32, and up to sixth half-life, we will be having 4 divided by 2, which is equal to 2 grams. Therefore, it takes 6 half-lives to decay from 128 gram to 2 gram. In the question, we have the total time, which is 42 minutes. So we can say that the half-life is equal to total time divided by the number of half-lives, which will be equal to 42 divided by 6, which is equal to 7 minutes. Hence, option B is the correct answer. Question 59 says that half-life is not affected by temperature, electric and magnetic field, pressure, all of these. We studied that half-life depends on only nature of radioactive sample. So temperature, pressure, electric and magnetic field does not affect radioactivity or the half-life. Hence, we can say that option D is the correct answer. Question 60 says that in which of the following decay proton to neutron ratio increases? Talking about the alpha decay, this involves the emission of an alpha particle which includes 2 protons and 2 neutrons, which decreases both the proton and neutron count but does not specifically increase the proton to neutron ratio. Hence, option A is eliminated. Talking about beta positive decay, in this process, a proton is converted into neutron. This increases the neutron count while decreasing the proton count. Thus, it results in increasing the neutron to proton ratio but not proton to neutron ratio. Hence, option B is the incorrect answer. Then we have the gamma decay. This process involves the emission of gamma rays and does not change the number of protons or neutrons in the nucleus. Hence, it does not affect the proton to neutron ratio. Talking about the beta negative decay, this involves the conversion of neutron into proton by emitting an electron and an antineutrino. This increases the proton count, thus increasing the proton to neutron ratio. Hence, option C is the correct answer. That's all for this video.